Well, time now to welcome on stage Einar Andreas Øvreness, and I hope I'm saying it right. Don't hesitate to correct me when you will join me on stage. You're a senior system engineer at EIDEL, one of our sponsors, the occasion for us to thank you for your support. And you will be talking about securing the Arctic surveillance satellites.
Yes. Yes, I come from the company EIDEL. My name is Einar Andreas Øvreness. And securing the Arctic Ocean surveillance satellite is an ongoing project and in Norway. Just about EIDEL first, it's a Norwegian engineering company established long time ago. We are now about 50 employees and still increasing. We have two business areas, space and defense, and we see the synergy between these two business areas in many ways. As you can see from the picture or figure, you can find us where man is not permitted to be, either because it's remote or a harsh environment. Can be unmanned assets or something with high precision or high security. We can also see in the figure some of the environment, like radar installations, then JSM or NSM missiles from Kongsberg, and also the AOS satellite, the Arctic Ocean surveillance satellite, up to the upper right corner. In Norway, the ocean is big, and we have fisheries, we have shipping, we have customs, border control, search and rescue inside this naval area 19. So the Arctic Ocean surveillance satellites will do surveillance within this area. Here's a picture from Svalbard. In the Arctic, there is a vast area rich on resources, a big ecosystem, but vulnerable. The polar ice is melting, which is bad for the polar bears, but provides access for boats. New possibilities also may inflict conflicts, and critical infrastructure is vulnerable. Civilian and defense sectors need to cooperate for situational awareness and operations. One of the instruments on board the Arctic Ocean surveillance satellites is an AIS receiver. AIS is a way of ships avoiding collision, but it can easily be turned off, despite legislation said that you should have it on. It can also be spoofed. So other instruments on the satellites in Norway provide ways of surveillance for boats or ships that are not cooperative. And the results of this might be classified, because otherwise, if they were not encrypted, the downlink could be used for training to get or not to be detected. But with the encrypted downlink, then you can't see if you are detected or not. Then the authority can do their tasks. So filling in, just to say, filling in the blank parts on the map was like turning on the lights. When the satellite provided the AIS receivers, also in the middle of the ocean and not only along the shore. So users of these satellites would be the Norwegian Coastal Administration, the Coast Guard, or the governmental users. It will be defense and NATO, and scientific and commercial organizations. So we speak of dual-use satellites. So what is dual use? Perhaps you know. One use is commercial and science users, where the security need is not very high. Then we have the civilian government. And both these might have unclassified use, sometimes due to GDPR and other things. Search and rescue operations might, for instance, be classified or sensitive. But then the third thing, intelligence or surveillance, is often highly sensitive and therefore have a high security level. And then operating these users at the same time means dual use. Perhaps not always at the same time, sometimes one of them, sometimes the other, because perhaps the civilian users should not know the attitude of the satellite, for instance. Okay, meet this one. This is the NCU, part of the satellite you see on in the picture. And part of the secure satellite link. This system was developed and is still developing. And the first use is on NorSat 4, which is a satellite launched in January this year. It was switched on the cryptographic protection in March, and this is still on. So this satellite is now secure. You remember the picture from Svalbard? It was taken from this satellite, sometime during commissioning. The keys for cryptographic protection inside here are loaded before launch. And then the keys are used throughout the mission, not for the traffic protection, but for key loading protection. So the keys used for traffic are loaded when needed. There are 3 links, one command uplink, one telemetry downlink, and one payload downlink. And the payload downlink is the one with the highest bandwidth. Of course, there is not the same device, but the similar functionality on ground called the GCU, the Ground Crypto Unit. and it is located in the control center, mission control, satellite control, at least in the control center and not at the ground radio station. So the ground radio station can be around where it is possible to have such equipment, and the control center is located where it is. Okay, so this comes just in the link between mission control or control center and the onboard computer. In this drawing, we use red for unencrypted data, plain text data, and we use black for encrypted data or cryptographically protected data. The SSL has the NCU in the satellite, and also we have a possibility for an IP core version because of the higher bandwidth, more than we can do in this unit. So we load the keys to that box also, that unit, the payload data handling unit. Having a physical device means that the onboard computer will never see the keys, will never bother about encryption. The only thing is the payload overhead coming from the ICV of the algorithm. And we are in the process of getting this system, get the classification for this system. In the control center, there is the similar equipment, but where do the keys come from? We actually generate them in the system, so we can provide new keys whenever necessary. So we do encryption and decryption on the TTLC links. So all the black communication in the middle, be it on ground or radio from ground to space and back, all that communication is protected, while the communication to the mission control at the bottom is indicated by red, so the mission control and the onboard computer communicates in the plane. But all the link in between is protected. For the payload downlink to the right, there is a decryption unit that receives the keys from the control center, and it's not necessarily co-located, so it actually can load the keys across an unclassified wide area network. And again, forwards the plain text data to the payload processing center, meaning that the data generated from the surveillance instruments are provided to the payload processing center. This is a physical product. It takes time to make, to design, to get approved. When we started, we had some elliptic curve elements in here, or planned for. Then we didn't use the elliptic curve elements any longer, because we wouldn't do that. Still, it has not got the PQC algorithms. That's the next step. So this is just symmetric encryption. The first one, the AES 256 GCM. The other algorithms in PQC are related to the protocol we have called CSAM key exchange for a system called CSAM, inspired by the Internet key exchange and the TLS, using FrodoChem and XMSS. This system we have used for getting knowledge about how to scale a system from just point to point to to many communication, establishing secure keys whenever you want to communicate. There are also things about the hardware that we must handle. An example is that you don't like poo in your drinking water. We won't have classified information into the unclassified environment. That's the name Tempest in the middle, if you didn't know. Okay, so when securing these satellites, we load keys before launch, and we use them for further key loading every day for more than 10 years. And the satellite is meant to work for 5 years, so it should be a margin. This is the timeline for EIDEL. We have an instrument on the ISS, not related to cryptography, but space. We have launched the secure satellite link on the NORSAT 4 this January. We are working with the microsar satellite for next year, and possibly a constellation the year after that. We are prime on the secure on the Arctic Ocean surveillance satellite, the demo satellite, using the secure satellite link. And we are providing the secure satellite link on the other Arctic Ocean surveillance satellite provided by Kongsberg. So the two Arctic Ocean surveillance satellites are made by different primes with the same cryptographic system. And we are also heading for another space weather measurement on later satellites. Just before Q&A, I provided some links, some sources. If you want to read more Norwegian, then an interesting reading from the Norwegian Coastal Administration and the Norwegian Defense Research Facility, in case the brief is distributed after the presentations. Good. Thank you.
Thank you very much. I will not be the one sending the email, but I am sure we can share the slides afterwards. Thank you very much. Please have a seat. You were right in enhancing the Norwegian responsibility in the Arctics, and it made a relevant link with what was told this morning by the chairman of the EU SPA SAB, Philippe Bertrand, about Norway being part of the Security Accreditation Board. Perhaps maybe we can insist on what distinguishes the SSL that you're proposing from competing solutions.
Well, it is that this is a physical units. So and this is due to the security level, so that the onboard computer is not bothered by doing cryptographic work. And it also means that you have a hardware acceleration on the cryptographic functions.
And how is SSL implemented on the ground?
As I said, is the GCU, which is a similar unit, but not made for the space environment. So that one we took from just made it again from what we had for the missile testing.
Okay. I invite here again the people from the audience to ask any question they might have on the Connects Me app. I don't think we have anybody now. I'll just keep on with ours. Will EIDEL assist with national approval of the system? And how?
If used in another country, we will provide the help as best we can. But in the end, it is the end user that must go through the process or driving this process through.
Mm-hmm. And do you, because we often refer to a jungle of regulation and standards, is it impacting you in what you foresee?
Of course, it's always different countries and different ways of but most of them are the same when it go through the first impression. Mm-hmm. So yes, we will try to help and provide or link up with or team up with the National Security Authority, using the Norwegian one as our entrance.
More on the technical aspects of the SSL. Can the system handle a constellation of satellites?
Yes, the individual satellite is not aware of any other, so it's only the ground system that need adaptation to more satellites.
Mm-hmm. Can you maybe share information on the delivery time? You've shown the timeline, the overall timeline.
Yeah, the timeline. So we work with projects that shall have launch in some years. We don't have any units on the shelf. We need to make them from the order. So it will always have some time because of the component market, and then if there is adaptations, that will take additional time.
Mm-hmm. You were the only one to bring a physical device here on stage, and I'm grateful that you did. What is it that you wanted to highlight with these?
To highlight this one, yes, it has a red side and a black side. It has serial interface on both. It has fire codes, so you can actually send and transmit fire codes to this one, and it will work like a fire code for whatever you use this fire codes for, but you will have them encrypted. You can also reset this by a fire code, and that fire code, when used, you can reload another code, so you can't do it again with the same one. Yeah, and then you can load keys both into this and from this to another device. So pretty much what you need.
Okay. and it seems quite light to carry.
Yeah, this one is empty.
Okay. I thought, well, I am glad that you allowed to put into the spotlight a region that has worldwide impacts. And talking about surveillance of the Arctics, there is also the Russian Arctica constellation. How do you position also your timeline within this context?
That is more for our customers to decide.
Okay.
But you know, you see the map?
Yep.
We are outside the map. So no, at least when we have our customers are the government, then we don't do decisions on the timeline. We try to deliver as they want.
Okay. We have a question from the audience. Thank you for answering all these we previously had. From Elmari Luoma. Has it been difficult to generate true random numbers for encryption, key generation, and what is your approach? Thank you, Elmari Luoma, for your question.
What to say? True random numbers, there is a definition in the NIST series of documents saying that this standard shall not be used for the actual implementation. So, and that's because not every implementation should be the same. So no, it is not difficult to generate the true random numbers, but you need to do it right. And then you should look to the standard saying, do not follow me.
This is your approach then?
No, we have had a nice dialogue with the Norwegian security authorities, so we have come to a solution. But with these authorities, they don't tip you off. They say no, or they say nothing. So we have tried to navigate through that.
And what about your dialogue with European authorities?
Always through the Norwegian ones.
Okay. Well, thank you very much. We are on time. I thank you for your presence here and also showing us the device, though empty, but I'm sorry I spoiled the surprise. Thank you very much. We can here again applaud you.